Hi, I'm General Buford. You see me in such fine quality, epic chemistry videos such as Black Powder and Chemistry. What's the connection? And I knew there was a purpose for the periodic table. Okay, this is our first part of Chapter 5, looking at the periodic table. If you look at the title page there, you'll notice there's no homework attached there. I will rectify that once we get started. Okay, here we go. Looking at the history of the development of the periodic table, it does show the process of model making in science. It didn't come about all at once. Hey, I'm in the way of awesomeness over here. There we go. So Lavoisier published a list of 30 substances that he called elements back in 1793. Okay, now some of those elements that he referred to were actually compounds, but we're not going to argue here. Okay, Dalton eventually ended up documenting about 60 elements at that point. So we're looking from the late 1700s now to about the early 1800s. Okay, he had a complex symbol system that would allow us to identify those pieces. Then we got another dude, Dobriner. That's about 1829. Now, what he noticed about it was that he came up with something called triads. Now, triads, when you think about the word triad, think about the word three, okay? Groups of three elements that shared similar properties. So, for example, here we look at alkali formers and salt formers. And if you were to notice here, if you look at the weights of these elements, you kind of notice, hey, there's some kind of a pattern here. Let's look at lithium, sodium, and potassium. Now, if you look from 7 to 23 and 23 to 39, the difference in the mass is, wow, the same. And that's where Dobereiner was looking at the pattern that he was seeing. That's why they referred to Dobreiner's triads. Three elements, groups of three elements that shared similar properties. And that's sort of the picture of him there. Some of those triads ended up becoming tetrads, which represents 4, and pentads, which represents 5. Periodicity, again, this happened every so often on our periodic table. Let's move on here. Well, we had Newlands, 1865, the end of the American Civil War. Organized atoms by atomic mass, used musical and math background to try to explain what was going on. He had 7 columns. He had something called the law of octaves, where there seemed to be a connection with atomic mass and chemical properties, about every 8 elements or so, hence the law of octaves. The downside about it is that nobody really particularly accepted the idea. So with that, okay, not much we can do about that. Let's move on here. And then there's Mendeleev. Mendeleev, he was a Russian dude, and he looked at the known elements at the time, and he arranged them by atomic mass. And what he did was he organized elements into this table that weren't yet discovered, but he knew something was up. He knew there were other things to be done. And that's where he came up with the idea of transition metals. Now, what does the word transition mean? Transition means changing. You are transitioning or changing. So you are in high school, you are making the transition from being a little kid to being a young adult. You are in the transition, you are changing, just to give you an idea. Now, there is also the idea of the periodic law, and Mendeleev sort of tried to explain it this way, and I'm going to cover up his picture for a moment. Properties of elements vary with their atomic masses in a periodic way. What does he mean by that? Well, what he was saying was how elements behaved, it depended on how much they weighed, and that was happening every so often. And that's where the periodic law came in. There seems to be a consistency with the periodic law that we are seeing that there are changes going on with these elements, that they have similar properties. And it's like this group has similar properties. And then you go down to the next row, and here's another group with similar properties. And that's what he's referring to as the periodic law. We move on now to the modern periodic law, because Mendeleev was back in the 1860s. Now we got Henry Mosley, and what he did, he looked at the properties of elements, and he said, hey, they vary with the properties of these elements, they vary with their atomic numbers in a periodic way. And that's a picture of Mosley right there. Okay. Now, the guy was killed in World War I, and scientists were never allowed to fight on the front lines again, ever. So, he worked with crystalline DNA, the crystalline X-rays of the crystalline forms of these elements. That's how he came to what he was coming up with. Okay, what else? We do have artificial elements in there. So we've had all these people, and they've come up with different pieces of the puzzle. But what did we see? We saw that there was consistency. We saw that there were similarities in properties, and that seemed to happen in patterns. And that is a very important idea. But now we have to talk a little bit about artificial elements. In the up here, you have Neptunium. Down here, we have plutonium. Now, these are called transuranium elements. Well, what do you mean by transuranium elements? We created those elements using uranium as our starting element. We messed with it. We ended up developing neptunium and plutonium. Now, plutonium we've used as a trigger explosive for an atomic bomb. Okay. Now, this is the products, again, of artificial processes. All right, let's get to the heart of the periodic table here. You've gotten the history. How do we read this? Well, there's different symbols here to look at. The main ones you need to pay attention to, the name, like uranium. U is the symbol, okay, and that's what you would see in a chemical formula. You have atomic number, that's 92. But remember, the atomic number tells us how many protons are in the nucleus. Remember, the number of protons in the nucleus tells us what the element is. If you change the number of protons, you've changed the identity of the element. Now we have here the atomic mass. Okay, wait, if we say there's 92 protons and we have 238 for the atomic mass, what does that mean? Well, it means you have a whole bunch of neutrons in there. You have many neutrons in there in the nucleus. That's why you've got the 238 right there. See, right down here. Now, what are these? Well, these are the electron structure by energy level. How many electrons are in level 1? Well, that's 2 of them, right? In level 2, it would be 8. Think it would correspond with 2s with 2 electrons in it, think last chapter, and 2p, 6. And then level 3 with 18, level 4 with 32, level 5 with 21, level 6 with 9, and level 7 with 2. Wow, what can I say about that? But that kind of gives you the idea of how the electrons are arranged in a typical uranium atom. So we have the atomic number, we have the name, we have the symbol, we have the atomic mass, and we have the electron structure by the energy level. And last but not least, radioactive for all you Fallout 4 fans. So when we look at a periodic chart, there's the vertical column, the column that's going up and down, and then there's the horizontal column, which is going side to side. Okay, so when we look at the vertical column, we call it the group. That's what you're seeing here. So we can look on a chart like group 1, group 2, group 3, and then period 1, period 2, period 3. Why would that matter? We'll talk about it. So Horizontal vertical column is the group. Horizontal row of the elements is known as a period or a series. I usually refer to them as periods. Okay, here you go. The entire periodic table in its glory. Okay, so as you can see, here's group 1A, group 2A, group 3B, 4B, and then we're going to go all the way down to group 8A. Now, I have to tell you something. The 8As, the 1As, the 2As, that's not very important. What's important is look up here. Group 1, Group 2, Group 3. Okay? And then here's 17 and 18. Now, if I had to sit there and say what was the most important parts of the periodic chart to know, it would be Group 1, okay? Those are our alkaline metals. Group 2 in the pink, that would be our alkaline earth metals. Group 7, which we would call as the halogens, okay? They're also nonmetals. And then last but not least, group 18, which happens to be our noble gases. Those are like the four most important groups to learn on the periodic chart. Now, what you see there in the yellow here, these are called the transition metals. So the left and the middle side of the table we refer to as the metals, okay? The right side of the table, we look at it as nonmetals. The metalloids share properties of both metals and nonmetals, so they kind of behave both as a metal and as a nonmetal. The lanthanide and actinide series are at the bottom of the table, and if we put in the lanthanide and actinide series right here, the inner transition elements, our periodic table would split apart, and we couldn't even fit that on a sheet of paper. Okay, can you imagine that? Okay, with that, I am stopping here for the history of the periodic table. This is General Buford, signing off.